What if you could feel an atom? Not see it, not estimate its position, but actually trace its shape. That's atomic force microscopy.
Most microscopes rely on light, but atoms are far smaller than light's wavelength, so light microscopes hit a hard limit. Atomic force microscopy solves this by using touch instead of sight.
Imagine reading Braille with the fingers sharper than a needle. An atomic force microscope uses a tiny probe, ending in a tip just a few atoms wide, mounted on a flexible beam called a cantilever. As this tip scans across the surface, atoms push and pull on it with incredibly weak forces, bending the cantilever by less than the width of an atom. So, how do we detect something that small? A laser bounces off the back of the cantilever and onto a sensor. As the cantilever bends, the laser moves.
That motion is used to build a 3D image of the surface, line by line. Let's look at some examples.
This is a raw 3D scan of stainless steel, which contains distortions due to sample tilt from mounting errors. Basically, it was slanted relative to the tip. This is a version corrected by scan line fitting, where data points are subtracted by a fitted mathematical function. Thank you, NumPy. The features of the material can be seen much more clearly here. In this case, the stainless steel was obviously really rough and bumpy. This is a scan of pyrochlorothenate nanofilm, showcasing all of the localized growths on its surface. The topography scan shows us the varying heights of the surface, while this amplitude scan shows us how much the tip vibrated at each point. And then this 3D view gives us a clear idea of how the nanofilm looks, as if you were looking at it with the naked eye. With this we can see that the tip oscillated more at the areas of growth, shown by the light spots on the scan. This is because the increased height of the structures bent the cantilever more. All these scans were taken by me and my partner at the Rutgers Quantum Materials Lab. Atomic force microscopy can remind us that sometimes the best way to understand the world is not to look harder, but to reach out and touch it.